Hello everyone, so welcome to the Graphics Programming Virtual Meetup. Today we will talk about the PBRT book where we talk about textures, texture interface and basic textures. So there are a variety of ways to generate 2D and 3D texture coordinates, so we will now define general interface for texture functions. PBRT support two types of textures, scalar floating valued and spectral valued. So for the first, there is float texture. There are currently 14 implementation of this interface, which leads to a lengthy list of types for the text pointer template. They just gather them into a fragment. Okay, just use inheritance to hide some noise. Float texture takes a texture eval context and returns a float value. Spectrum texture is equivalent but for spectral textures. So it's something like this also. Spectrum texture evaluation routine does not return a full spectral distribution, but I can't remember what's the reason. Take a set of wavelengths of interest and return a texture value just at those wavelengths. Yeah, I guess that makes sense. So constant texture retains the same value no matter where they are evaluated. Because they represent constant function, they don't need AA. Yeah, because they can be reconstructed at any sample rate. You just need one sample basically. And though these two textures are trivial, they're actually useful. By providing this class as our parameter to all materials can be represented as texture rather than whether they are spatially varying or not. Yeah, just like don't have a special case for like a single color or a texture, which I think in my Vulkan render I do the similar thing, like just for something which is a single color I just have a 1x1 texture for it. Red diffuse object will have a spectral constant texture that always return red as the diffuse color of the material. They are avoiding needed to separate textured and non-textured version of materials. And yeah. Just evaluate, ignore the parameter, just evaluate to this value. Spectrum constant texture is similar. Just it have a constant, what's it called? The value, but it's not a texture, it's a spectrum and it's sample from it. sample from this SPD, I guess, yeah. And scale texture. This is a texture interface in a way that makes it easy to use the output of one texture function when computing another, which can be used to define generic texture operations to use other textures. So kind of like a OOP decorator kind of idea. Float scaled texture takes two float valued texture and return a product of their value.
It's the product of two textures, I guess. Value.
Not well, you can't product two textures, but the product of two samples from the two. Yeah.
Right.
Scaled textures ignores AA to leave it to subtextures to AA themselves, and not make an effort to AA their product. It's easy to show the product two band limited function, also band limited. The maximum frequency presented in the product may be greater than that of either of two terms individually. So even if the scale and value texture are perfectly AA'd, the result might not be. Fortunately, most common use of this texture is to scale another kind of texture by a constant. So yeah, in which case we don't need AA. Thing to notice in the implementation of evaluate method is it skips evaluating the text texture if the scale texture returns 0. Yeah, just optimization. Okay, so just use this scale idea, like using one texture as a mask for another.
Okay, yeah, that seems like an interesting, yeah.
Yeah. Spectrum scaled texture is just a variant. And this mixed texture, which I don't know the difference, let's read below. The more general variant of the scale. Okay, oh, the blend. So they use another texture as a blending factor. Or they can use an even more complex texture to be used to blend in a spatially non-uniform way. to evaluate the mixture, the three textures are evaluated, and the Fe value is used to linearly interpolate between the two. When the blend amount is 0, the first texture value is returned. Okay, I guess just read the code. You just get the amount. And also to evaluate those two textures. I guess those branches is just because evaluating textures can be expensive, so use branches to try to avoid that, and then doing lerp at the end. Spectrum mix texture is also parallel to float mix texture.
I guess too, if you were building up a texture system here, those could be recursive that evaluate.
Yeah, it is recursive. It is there, so this evaluates some other textures, right? So it is recursive, but it also have like runtime polymorphism mixed in. Even though this is not exactly OOP, they use some of the attacked pointer stuff, but the idea is similar. And blend between two textures based on surfaces orientation. Float direction mix texture and spectrum direction mix texture use the dot product of the surface normal with the specific direction to compute such a weight. Okay.
Like a triplanar mapping kind of thing, where you based on the normal.
Texture is used to select between one image texture that use planar projection to specify the cover image of the magazine, and another that use a different planar projection for its spine. Okay.
Interesting.
Yeah. I guess it's just a more general way to implement something like cube mapping or like whatever weird mapping scheme that based on directions. Which is dot. Yeah.
That's interesting. I guess you don't have to have UVs for your models if you do it that way, necessarily. Or
You still need to have UVs, just like UVs used to sample from like this underlying texture, basically. Where in here, I guess UVs in the context which they just forward to the underlying texture. And at the end, underlying texture is image, you still need UV, right? Yeah. Texture
it's an interesting way to.
Yeah. You still have all those stuff in it. Yeah. This chapter, pretty short. Let's see. The next is maybe let's do it next time. So next one is a bit long and also, yeah, doesn't look easy. Because they need to implement something like map mapping in software, right? So
Mm.
yeah, let's do it
That's
next
tough.
time.